All right, I'd like to give you a quick overview of this cool project I've been working on. I've actually been working on this for 5 years, on and off, mostly off. But with the advent of Claude Code and LLMs, it was easy to get over a hump that I got stuck on back in 2020 and actually make this work. So here's the idea. I'm running IntelliJ right now. In the background, I've got a communication daemon running, and I'm also running sort of a syntax analysis thread in the project. You can run that as a separate processor in there. So basically, there's a thing I can trigger from the REPL if I wanted to, that would look at the source files and do the stuff I'm about to show you. So if you're not familiar with Guardrails, that's what this is sort of based on. So in Guardrails, you can specify greater than sign here, and then you can give a specification, and I'm using Clojure spec right here, to say what your argument types are. In this case, I can take anything, and I should return a Boolean. And then this marker is a Guardrails Analyzer marker that I'll talk about here in a minute, that just says the function's pure, doesn't side effect, it's safe to sort of use it however you want, because this is actually sort of, it's simulating running your code with generated values in order to then analyze the code to figure out if there are problems. So if you look, I've already got markers here, and I've got an IntelliJ plugin that I made, and so I can say basically check namespace, and it'll run the analyzer on it and show me markers. And so this marker says, oh, well, your argument V, well, anything could come in, and like nil, for example, and contains may not work right on that. And so, yeah, sure enough, we probably should say, and that's a map. All right, so that clears up that error. So let's check namespace and see what comes up next. All right, so now it's giving me a thing that says, all right, the then branch, so and short circuit. So it's basically telling you it's potentially unreachable because the samples that I played with didn't get me there. So I'm gonna check the namespace again. I was hoping it would come up with an alternate explanation here. Now, let's leave that one for now. So down here on, and it takes the markers away as I go, down here on new person, I've got a message here that says, again, the then branch is possibly unreachable. Now this sort of tells you where this sort of can go wrong a little bit. The pure marker tells the system that you can it can run code to generate values, and so what it was doing there is it was generating random numbers and never getting anything over 0.5 for the sample set, and so it didn't see both branches reachable. So I actually loaded the file and then rechecked the namespace, and you saw that one go away. So this is one of the kind of weaknesses of generation-based testing. Now, here's the thing that I was trying to get over a hump on, and that's that if there's a conditional, you kind of have to split the world, right? You have to test, all right, well, what if that was true? Well, then that's bound to whatever happened here, and otherwise it's bound to whatever happened there. So in this particular case, along this arity of the function, it's possible for full name, which adds a full name attribute to the person, to not be called. And this output of this thing says full name is going to be set. So if I look at the messages here, it can say, oh, well, the function says I'm going to return a thing that has full name in it, but I found an example where full name didn't pop out, and that happens when this thing causes me to go to the else branch on line 38. So it actually did like a walkthrough of the code and tells me, all right, yeah, you said that's what you're going to get, but sometimes I found a case where you're not. And then down here, you can see the else branch is potentially unreadable. So the samples that it passed through here, well, person was always true. And so we always got person 2, and person 2 matches the spec. So we didn't get an error on the output, but we did get an error here saying, yeah, do you need the if? That's kind of, you're not actually, going anywhere with it because the person's always a person. So if I change this to maybe false and check the namespace, now I'll get a secondary error here that says, oh yeah, on line 50, yeah, we always go to else, and then we get a keyword error out at V. And so that's no good. So then I can also check things like this, where it says, hey, wait, 99, that's not a string, right? That's what person last name has a different spec up here. The spec is a string, and you're putting a value there that's not right. Now notice that the binding flow here is followed. So I'm still going to get the error here that, hey, the expression foo could potentially have the value 49. It always has the value 49, right? Which does not conform to the spec. And down here now I'm getting a thing that says, oh, you know what? This guy wants a person, and I'm getting samples that say my last name's a number, and that's not good either. And of course that's resulting in a return error that's saying, yeah, I'm getting crap out under these conditions. So it's actually walking samples through your program to see if you've got potential problems. Now, if I were to change this to say, I'm going to take a map and tell you whether or not that map is a person. This might, let's see what, oh, I didn't check the, oops. Like I said, it's a little rough around the edges, and I think my plugin just lost the connection to the daemon or something. Let me undo some pieces here, and yeah, oh no, it's still running. Okay, good. Yeah, I was trying to show you this this one case that this guy that is the error, right? So it's telling me that the branch is potentially then branch samples never yielded a truthy value. Okay, so this is my analysis not giving me exactly. This is basically telling me I forgot to cast that to a Boolean, and so now that results in that. I was remembering for some reason that it would mark it here, but clearly it's marking it there. So you can see this is catching a lot more interesting cases than just a plain static analysis can catch. And I have gone ahead and it's real easy now with LLMs to generate definitions for library code. So if you've got some library you use and they haven't used guardrails, you can extend it into guardrails. The other thing is the analysis is actually pretending to run the code and propagating the data through its simulation, and that's extensible. So in Clojure, you probably know that if itself is kind of a primitive. I mean, it's defined as a macro, but the macro calls, I think, if star or something like that. I don't know. Different Clojure versions might have different specifics, but basically if is a primitive. But something like cond or cond thread or any of those macros actually just evaluate to ifs, right? They evaluate to conditionals underneath. And so there's a multi-method implementation where you can teach Guardrails Analyzer how to convert your macro-like things into something simpler that can then be analyzed. So this is extensible, right? So if you have, whatever you've got in terms of your code structure, your macros that give you syntactic advantages, this is a local analysis, right? It's not actually expanding macros or anything. What it's doing is, well, it's literally like there's a multi-method definition for how to interpret let, and there's a multi-method definition for how to interpret if, etc. So I've kind of covered the major constructs of the program, and then other things are just function calls. And this marker pure tells Guardrails Analyzer that it's safe to actually call that function in the Clojure runtime to propagate the values. Because if you can't propagate the values, then you don't necessarily get the right things out. Oh, I forgot to show you the bindings. So when you hover over in the IntelliJ plugin, Guardrails Analyzer actually tracks by line what the different bindings have in them as a sample set. So here I put a single sample in there by letting it be this exact one thing. Up here, first name, if I hover over that, it says, oh yeah, it could be an empty string, could be I, right? It's giving me some sample values. I haven't added, or maybe I did and I don't remember. There might be controls for the number of samples it generates. I don't remember how I did that. But certainly you can define generators on your defs of your properties. So for example, you could define a generator on person first name that gives, Tony and Sally and Joe and some, some ones with accent characters or whatever. And then whenever the generator tries to generate values for that, it'll generate one of your known values, which will make reading this stuff, go nicer. And so down here, person two, you see the sample values have the two possible branches of the if, right? On one branch, you're getting a last name that has a full name that has a string in it, and then the other one, you're missing the full name, right? Now, it does do a path-specific analysis. So as you walk the sequence, the more conditionals you have, the more it has to make fork the universe of possible values and track dependencies. And so it does do that. That's the thing that I'd been hung up on and I knew kind of how to do but didn't feel like coding it, and an LLM actually did a really nice job of. So this isn't quite like super nice to use yet, but I hope you see that the value it could potentially bring to your project.